All right, let's dive into something pretty cool today. We're talking about GPU pass-through on an unprivileged LXC running rootless Docker in Proxmox.
Yeah, it sounds a bit intimidating at first. I know. But stick with us. It's really not as complex as it might seem.
Okay, I'm intrigued. I mean, I know a bit about LXCs. They're like lightweight virtual machines, right?
Exactly. Think of it as a contained space on your computer, just for running a specific application.
Hmm, interesting. So why would someone choose an LXC over a full-blown virtual machine?
Well, for starters, they're super efficient. They share your computer's core, the kernel, without all the overhead of a full virtual machine.
So it's like giving an app its own little apartment within your computer.
Precisely. Now imagine you want to give that app access to your computer's graphics card.
Ah, that's where the GPU pass-through comes in.
You got it. Instead of just sharing the basic resources, we're giving this LXC access to the GPU.
I see. So why would we want to do that? I mean, what's the advantage?
Well, think about an application like Jellyfin. It's a popular media server, and it can really benefit from having access to a GPU.
How so?
It means Jellyfin can use the GPU to process video, which makes playback smoother and takes the load off your main processor.
Okay, that makes sense. We've got the LXC and the GPU pass-through. But what about this rootless Docker thing?
Ah, that's all about security. You see, running Docker with root privileges, it's like giving an app unrestricted access. Too much power.
Oh, I see. So rootless Docker kind of puts a limit on what the app can do.
Exactly. It limits the app's access. So even if there's a security issue, the damage is contained.
So it's like a security guard at the door of our app's apartment, making sure it can't just wander around the entire system.
That's a great analogy. Now let's get into the nitty-gritty. How do we actually set this up? Well, first, we need to enable GPU pass-through in our LXC.
And how do we do that?
Well, we need to tell the system which GPU we want to use and who's allowed to access it. We do that by adding a specific line to the LXC's configuration file.
Okay, so this configuration file, it's like a rulebook for the LXC. What does this line look like?
It's like this: .devu0, .devpath to GPU, the LXCs. That devpath to GPU part, that's the location of your GPU, which you can find in your system's hardware information.
Okay, and what about those UID and GID things? What are they all about?
Think of them like security badges. They specify who can access the GPU. UID is for the user, and GID is for the group.
So the UID would be for the user running our application inside the container.
Exactly. And the GID usually refers to the render group, which has permissions to use the GPU.
All right, so we've pointed to the GPU and given our application its security badge. What's next? Does it automatically know how to use the GPU?
Not quite. We need to configure it, and that's where Docker Compose comes in. It's a tool that helps us manage our Docker applications.
So Docker Compose is like the architect, designing how our application interacts with the LXC and the GPU.
Exactly. We need to tell Docker Compose to map the GPU device from our host to the Docker container where our app is running. And that mapping happens in the docker-compose.aml file.
Okay, so we're creating a connection between the host GPU and the application container.
Yeah.
What about that rootless Docker setup? How do we make that happen?
Right. So for rootless Docker, we need to make a few tweaks. Think of it like fine-tuning the security protocols for our application container.
Right.
We need to modify a file called etc.subjid.
Okay, what does that file do?
It controls the group IDs that are available for Docker.
And why do we need to modify it?
Think of it as expanding the guest list. We need to give Docker access to a wider range of user groups so it can manage everything securely without needing root privileges.
So we're basically increasing the range of IDs Docker can use.
Precisely. We're increasing the range of GIDs for the root mapping to make sure Docker has enough flexibility to manage users and groups within the container, securely, of course.
Okay, makes sense. What else do we need to do for this rootless setup?
Next, we go back to that LXC configuration file, the one we edited earlier for GPU pass-through. We're going to add a couple more lines to ensure seamless networking and proper ID mapping.
So more rules for the LXC rulebook.
Got it.
What do these lines do?
The first line mounts the Devinetten device. That's essential for Docker networking.
So without it, our container wouldn't be able to talk to the outside world.
Precisely. Then we add two more lines that deal with ID mapping.
ID mapping.
Yeah, they're crucial for making sure rootless Docker can function correctly and securely. They extend the mapping of user IDs and group IDs, giving the container a wider range to work with.
I see. So we're making sure rootless Docker has enough IDs to manage users and permissions without needing root access.
Exactly. Now, Remember those ELIG and GID placeholders we talked about earlier?
Right, those security badge numbers.
We need to find the actual values for those.
Okay, where do we find them?
We need to do a little digging.
Yeah.
Inside the LXC container, once we're in there, we can use a couple of simple commands.
All right, lead the way.
First command is edu. That'll tell us the user ID for the current user within the LXC.
And for the GID, for the render group.
We use the command git in group render.
Yeah.
It'll give us some information about the group, including the GID.
Perfect. We'll grab those numbers and plug them back into our GPU pass-through configuration line.
Exactly. And with that, we've got our GPU pass-through configure, but we've only just scratched the surface. We can actually pass through more than just the GPU, you know?
Wait, really? What else can we pass through?
Well, let's say you want to give your container access to a specific sound card for better audio processing.
Wow. So we can really give our LXC access to all sorts of hardware.
That's right. It really opens up a lot of possibilities for customizing your LXC environment. But I'm sure you're thinking, wouldn't it be a pain to manually change the ownership of these devices every time the LXC starts?
Yeah, that would get old fast.
Well, luckily, there are ways to automate those changes, which we'll dive into in the next part of our deep dive.
Sounds good. Looking forward to it.
Welcome back to our deep dive into GPU pass-through and rootless Docker. Last time, we talked about a lot of setup stuff. Are you ready to dig in a bit deeper?
Yeah, absolutely. Now I want to see what we can actually build with all this. So we talked about how Jellyfin could benefit, but what other applications could we use this with?
Well, that's the great thing about this. It's really versatile.
Yeah.
Anything that needs a boost from the GPU could use this. Like, imagine running, demanding games or video editing software, even complex machine learning applications.
Oh, yeah, I see what you mean. That's a lot of possibilities. Okay, so we've got the performance side, but what about the security benefits? You mentioned how rootless Docker helps. Can you explain that a bit more?
Sure. Think of it this way. By running Docker without root privileges, we're creating a sandbox for each application. So even if a container, were to be compromised, the attacker wouldn't have access to the whole system.
So it's like that security guard analogy again?
Yeah, exactly. It's all about limiting the damage. And this security doesn't mean we lose performance. In fact, we usually see a big boost in speed and efficiency because we're using the GPU.
Yeah, that makes sense. It's like we're giving these applications their own express lane, to the hardware.
I like that analogy. And don't forget those UID and GIG values. They're like security badges. Only the right application can use the GPU.
So it's like multi-layered security. We've got isolation and limited privileges and those access controls. But you mentioned earlier that Proxmox doesn't actually recommend running Docker inside an LXC. Doesn't that, affect these security benefits?
It's a good question. The security is still good, but it's important to remember that Proxmox might not officially support this.
So if something goes wrong, we might be on our own to fix it.
That's right. You get all this flexibility and power, but you also have to take more responsibility. It's like going off-roading.
Yeah, you might find some amazing places, but you got to be ready for, the unexpected.
Exactly. You got to know the challenges and decide if it's worth it for you.
Okay, I get it.
Yeah.
Let's talk about something we mentioned earlier, that automation stuff. You said there were ways to automate those ownership changes. Could you explain those more?
Yeah, for sure. Remember, we don't want to be changing those permissions by hand every time. So let's start with pre-start hooks.
Okay, what exactly are those?
It's like a checklist for your LXC, a set of commands that run automatically right before it boots up.
Ah, so we can use this hook to automatically change the ownership of things like the GPU before the LXC even starts using them.
That's it. We add a line to that configuration file. That tells the system to run a command before the LXC starts. The command's called chown. It changes the ownership of files and directories.
So we'd be using chown to change the ownership of our devices. To the right, UID and GID.
Precisely. So that line in the configuration file would look a little something like this. lxc.hook.prestart.prestart sh-h chown 101,000.104 dev path to device. So that first part, the lxc.hook.prestart, that signals that it's, pre-start hook. And then the SAC means we're running a shell command.
Got it, yeah.
And then we have the actual chown command, chown 101,000.104 dev path to device. That's what changes the owner of the device. To that user ID, under 1,000, and the group 104, the ones we set up before.
It's like prepping everything beforehand.
Yeah, exactly. You're getting it.
All right, so that's pre-start hooks. What about ACLs? You mentioned those too.
Right, ACLs. Or access control lists. These give us more specific control over permissions. So instead of changing the owner, we can use ACLs to grant specific permissions to specific users or groups.
Oh, okay. So it's like a VIP list for your device. Only certain users get
You
access.
got it. And for this, we use the command setfacl. For example, we could use something like setfacl natchem ubot101000.rwdevpath to device.
Okay, and what's that doing?
That's giving read and write permissions to the user with the ID 101000 for that device. So we're saying, hey, this user can use this device, but they don't own it.
Interesting.
And the great thing about ACLs is you can get really specific. You can give read-only access, write-only, or even execute permissions.
So it's like having different levels of access. That seems really helpful, especially if you have multiple users.
Exactly. Let's say you have multiple users, and you only want some of them to access a specific GPU, maybe for something like machine learning. You could use ACLs for that.
Yeah, I see how that would be useful.
Exactly. Or think about a development environment where, multiple people need access to the same GPU, but with different levels of control. ACLs can help with that.
Right. So ACLs give us that fine-grained control to manage permissions without compromising security or performance.
Exactly. You said it perfectly.
Wow, this is pretty cool. I think I will need to research ACLs more after this. But for now, maybe we should move on. Welcome back. I'm still thinking about all those ACLs and how we can use them. But I'm ready to wrap up this deep dive into GPU pass-through and rootless Docker.
Yeah, it's been a pretty in-depth look at this setup. We've covered so much, from like the basics of LXCs and GPU pass-through to rootless Docker and even automation.
And we talked about those support implications too, right? Running Docker inside an LXC, our listeners should definitely keep that in mind.
Absolutely. It's important to think about the benefits, like flexibility, better performance, and that security boost. But also, remember those potential challenges.
Yeah, like we said, it's a bit like going off-roading. There are amazing things to discover, but you need to be prepared, right?
Exactly. You've got to make those decisions based on your own needs and how comfortable you are with things like this. But, even with all that, the potential here is pretty huge.
I agree. And we talked about Jellyfin, but it's really bigger than just one application. It's like we're changing how we think about virtualization.
That's a good point. We're really blurring the lines, right, between physical and virtual, giving those containerized apps access to like hardware they wouldn't normally have.
It's pretty exciting, like all these new possibilities for LXCs and Docker.
And we're doing it safely, too. I mean, that rootless Docker is so important. It's a real game changer for minimizing risk.
Yeah, I think our listeners probably get it by now. Running Docker without root is essential. It's that security checkpoint, right, at the entrance of each container.
Yep, exactly. By limiting what those containers can access, we can really reduce the impact if, there's a security problem.
So even if something happens, the attacker's stuck. Can't do any damage to the rest of the system.
Right. And, we haven't even lost performance. We're actually seeing improvements because of the GPU access.
So it's like best of both worlds. We get all the benefits, but it's still secure.
Exactly. And don't forget those automation tools, the pre-start hooks and ACLs. Those make managing all this so much easier.
Yeah. We can just automate those boring tasks, and focus on the more interesting stuff.
Exactly. And that's the beauty of all this, I think. We can have this control and customize things, but we're not sacrificing security or performance.
Yeah. It's pretty amazing.
Yeah.
And this deep dive, I think, has been a great way to explore all of this. We started with something complex, but we broke it down into parts that are, easier to understand.
And we talked about those real-world applications, too, right? It's not just theory.
Definitely. I hope our listeners feel empowered, to try new things, explore these technologies, and see what they can do.
That's what it's all about, pushing those boundaries and seeing what's possible.
So thanks for joining us on this deep dive. It's been a great discussion. And to our listeners, keep experimenting and keep learning.
Until next time.